Hello everyone, I'm Chen Guangwei. I'm a graduate student from Institute of Electronics, National Yangming Jiaotong University. It's a great pleasure to present our work at this year's VLSI Design CAD Symposium. And today I'm going to talk about our work, an end-to-end neural network with a clustering enhancement for a configurable online speaker diarization. Here is today's outline. First, I will begin with a brief introduction to speaker diarization. Next, I will go into some background knowledge. Then I will explain our proposed methods and present the experimental results. And last, I will summarize our work. Let's start with the introduction. During a speech, human voice actually contains an amount of information. For example, the accent of the speaker, the language being spoken, the contents of the speech, or even the emotion conveyed while speaking. These tasks aim to extract specific information from speech. One such task is speaker diarization, which is used to determine who spoke when. In Chinese, 谁在什么时候说话. And what is the difference between the speaker diarization and speaker recognition? The speaker diarization deals with the issue of the multiple speaker in each speech utterance, and we want to separate the audio segments of the different speakers. The speaker recognition deals with only one speaker, and we want to know who is speaking. Next, we are going to the background of the speaker diarization. There are three common frameworks for a speaker diarization: multi-stage approach, end-to-end approach, and the hybrid approach. The first method, multi-stage approach, is the traditional method that divides the entire model into three parts: voice activity detection, speaker embedding, and speaker clustering. The advantage of the multi-stage approach is its ability to handle the scenario with the multiple speakers. The second method is the end-to-end approach, which uses a single model to replace the multiple stages, and this method is good at handle speech overlap. The third method is a hybrid approach, which combines the strengths of the both. It can effectively handle speech overlap and the multiple speaker problems, and this is a framework we use in our work. There are three main design challenges for a speaker diarization. The first challenge is multiple speaker and the flexible speaker. The second challenge is a speech overlap. And the last challenge is real-time processing. There is a matrix called real-time factor, RTF. If RTF is smaller than 1, and it indicates that our model can achieve real-time processing. Here is the performance matrix to evaluate the speaker diarization model, which is diarization error rate, DR. It means the error rate of a speech segmentation. There are two types of DR matrix. The type 1 is a simplified version, and the type 2 is a general version. The main difference is whether they take misdetection and false alarm into account. We will evaluate the performance using the second version of the DR. Next, we will explain the methods we proposed. Here is our proposed framework. First, the audio will be buffered in the streaming rolling buffer. Next, the preprocessing includes two parts: super resolution and the pre-emphasis. Then the audio data feed into the speaker diarization model, which include an end-to-end speaker segmentation model and the incremental clustering. Finally, the post-processing selects the threshold for the clustering, and we get the results of speaker diarization. To realize real-time processing, we introduce a method of a streaming rolling buffer. This rolling buffer divides a long audio into small sequences, which can sequentially fed into the model. The rolling buffer size is adjustable. However, as the buffer size increases, leading to a higher latency and a lower accuracy. For our implementation, we utilize a buffer size of 5 seconds, with a latency ranging from half a second to 5 seconds. The RTF falls within the range of 0.15 to 0.18. In the first step of preprocessing, we use super resolution to enhance the audio quality. Traditionally, super resolution methods include interpolation techniques. In recent approach, neural network can also achieve audio super resolution, like mu gain. We observed that using mu gain for a super resolution has significantly reduced the DR, leading a good improvement of our model. The second step of the preprocessing is pre-emphasis. This process passing the audio through a high-pass filter to enhance the higher frequency, which typically correspond to the human speech segments. Experiment has shown that applying pre-emphasis can reduce the DR and enhance the performance across a different number of speakers. Next is the speaker diarization. The end-to-end segmentation model consists of three main components. SyncNet for feature extraction. LSTM enables the model to learn temporal dependency among the data. Fully connected layers serve as the final classification layers. And why do we use SyncNet as the first layer? Because the general convolution methods will be more susceptible to the noise and the high dimensional input. To solve this problem, SyncNet learning the high and low cutoff frequency of parameterized bandpass filter, which can make it more robust. And here is the speaker cluster methods. As the number of the speaker may increase over time, we use incremental cluster to handle this problem. We map in the speaker embedding to represent the speakers and decide if the embedding belongs to existing cluster or not. By this approach, we can dynamically adjust the number of the speakers. In the post-processing, we choose the threshold of speaker clustering. There are three parameters that need to be chosen. First is the activity threshold. It is used to determine the activity speech segments. Next is a new cluster threshold. It is used to decide whether a new embedding belongs to a new cluster. Last is a duration length threshold. It decides how often the speech segments should be updated. Next, I will show our experimental result and comparison using two common datasets in the field of the speaker diarization: the mini-Libet-rich dataset and the Coulomb dataset. Because of the lack of diarization data, we use a method called a simulated mixture algorithm to augment the training data. In this method, we randomly select the number of speakers, and we concatenate these segments and mix them with a background noise to create the simulated mixture samples. In the mini-Libet-rich dataset, we mixture with 2 to 4 speakers. Our proposed method in the 2 speaker is greater than other works, except for the offline end-to-end approach. However, the offline end-to-end approach has 2 drawbacks. First, it cannot achieve real-time processing. Second, our proposed methods beats the offline end-to-end approach in handling multiple speaker situations. Next is the Coulomb dataset. We train our proposed method using a 10K simulated mixture of the mini-Libet-rich dataset. Our proposed method can handle both 2 and multiple speaker scenario. It is outperforming than other hybrid methods. Compared to a method which is specifically designed for either 2 speaker or multiple speaker, our model's DR is slightly worse, but our model has the advantage of online processing and the ability to handle both 2 and multiple speaker situation. And here is our demos video. Please take a moment to enjoy it.
欢迎收听百灵果 News， 这里是华语界最自由的双语国际新闻。
Welcome to Bilingual News, the freest international news podcast in the Chinese-speaking world.
我是凯莉
This is Ken.
我们会用百灵果双语的方式与大家聊聊世界各地有趣的新闻。
We'll be using both English and Mandarin to talk about interesting news happening around the world.
你也讲太快了吧？
很急啊！
没有，因为我刚把范姐赶走，好爽哦！
不是，我们今天时间不够，要开始。
不是，因为敏迪一早来，然后跟我们聊了1个小时，然后给我们看一些奇怪的影片，然后我就想说，你们要开始，你们知道今天很赶吗？
给我看影片的时候，我还跟他说，拜托我们到边边去，因为
对这个影片有点奇怪，
很怕我被员工告的。
And finally, here is our conclusion. In our approach to enhance the performance of speaker diarization model, first we use super resolution to reconstruct the audio resolution and improve the audio quality. And we use pre-emphasis to amplify high frequencies to highlight the human speech. Next, to overcome challenges in the speaker diarization, we use incremental clustering and the threshold choosing to realize the multiple speaker scenario. An end-to-end segmentation model to overcome the overlapping speech. And a string rolling buffer achieve real-time processing with RTF ranging from 0.15 to 0.18. As a result, our approach demonstrates performance in both two-speaker and multiple speaker scenario. On a two-speaker dataset, we achieve a DR of 13.09%, while on the multiple speaker dataset, we obtain a DR of 18.97%. And here is our reference. That's all from me today. Thank you.